Okay, so what we've been doing is looking at multi-step equations, solving them when we have to combine like terms, as I have right here, and then all different types. We've done two-step and we've done some inequalities. We actually did these were the tests. But then we did Don't Call Me After Midlife, we did Midnight, and we did some extra multi-step equations. So if there's any additional ones that you guys would like me to go over, just let me know. The other thing what I wanted to start on today was the fact that sometimes you can have no solution and infinite solutions as your solution to an equation. And that's always a little weird because what happens is that the variable goes away, and I'm going to take you through these two options. So what happens, so what I do in a normal situation here, oh, I'm not recording, hold on. I always forget to record. Oh, it says I am. I guess I am. Okay, just double checking. All right, so what I need to do is I have to distribute first. So again, look what happens. I distribute this 4 in here and I get negative 8x minus 4 is equal to negative 8x minus 2. Now here's a big red flag. If you see right here, there's a negative 8x and negative 8x on both sides of the equation. When the variable is the same with the same exponent, what happens, or the same coefficient, is when I try to bring one variable to the one side of the equation, that variable cancels out, right? So then I end up with an equation of negative 4 equals negative 2. Well, that never is true, right? So when the two numbers are completely different and the variable goes away, there's no possible number that could work, so there's no solution. Now, conversely, there's sometimes an equation like this one where we distribute here and I get negative 5 minus 9x is equal to 3 minus 9x minus 8. And so again, I have negative 5 minus 9x equals negative 5 minus 9x. We end up with the same exact thing on both sides of the equation. And then when I'm adding, I get rid of the variable. What happens is I get negative 5 is equal to negative 5. So when there are infinite solutions, when I go and I cancel out my variable and I get number is equal to number, there's two things that could happen. One thing is that if the numbers are exactly the same. If the numbers are exactly the same, then there are infinitely many solutions because no matter what x is, that will work, okay? If the numbers are not the same, then there is no solution where that would work, so that would be no real solution. So I'm going to give you a couple of examples. Now, some of these will have a solution, some of them will have infinite solutions, and some of these will have no solutions. But I just wanted to go through a couple of examples like that. So, and again, the more practice you do with solving equations, the better off you're going to be. So let's go ahead and try this one right here. So if I distribute the 3 into this, I get 6x plus 6 minus 3x is equal to 6 plus 3x. So I combine like terms on either side of the equation and I get 3x plus 6 is equal to 6 plus 3x. Well, as you can see, those are exactly the same. We know that by the commutative property, that if you change the order when you're adding, the sum is exactly the same, no matter what. So let's go ahead and subtract 3x from each side. And it says 6 is equal to 6. All right. Now, you're going to hear different people call it different things. Some people are going to say the solution is all real numbers. Some people are going to say, oh, there's infinite solutions. And then some people are going to say identity. Now, I don't love the identity. I don't love it when they say identity, but that can be, that is sometimes what you hear. So I don't think it's a really accurate way of describing it, but that's neither here nor there. People who are smarter than me came up with that. So any of these three solutions will work in this situation, as long as when the variables cancel out, the numbers that are left are equal to one another. Okay. So let's try this one. Now this one, I think we're going to actually end up with a solution. So I'm going to distribute the 6 and I get 12x minus 36 is equal to 14x minus 28. Sure enough, I'm going to have a solution to this system of equations. So what I'm going to do is I'm going to bring the variable to one side. I'm just going to bring it over to the left side by subtracting 14x. Doesn't matter if you brought it to the right side, it's totally fine. You can end up with the same solution. As long as you're using your reasoning correctly, you are fine. That's one of the nice things about math. There's usually more than one way to come up with an accurate solution. So we've got negative 2x minus 36 is equal to negative 28. So I'm going to add 36 to both sides of my equation. And I get negative 2x is equal to 8. And I divide by negative 2. And I get x is equal to negative 4. So I actually had a solution to that system of equations. Okay. All righty. So far, so good. All right. Here we go. Okay, so let's keep going. Having lots of fun. Being able to practice this and do as many equations as you can is really something I'm going to encourage you to do. Utilize Delta Math in these situations so that you guys are really comfortable. And while you're doing the Delta Math, you're actually doing practice for your retake, which is, I just love it the way that it works out with that. So that's just me. So anyway, so we're going to go ahead and distribute here on both sides. So remember, don't call me after midnight. Don't call me after midnight. So I distribute. So I have 40x minus 24 is equal to negative 18x minus 24. Okay, this is a great one. I really actually like these types of equations because watch what happens. I'm going to add 18x to both sides of the equation. And I get 58x minus 24 is equal to negative 24. Be really careful that you keep those signs that are in front of those variables and those numbers. So look what I'm going to do here. I'm going to add 24 to both sides of my equation, and I get 58x is equal to 0. By dividing both sides of the equation by the coefficient of x, which is 58, I get 0 divided by 58. 0 divided by any number is 0. So x is equal to 0. Okay, so a lot of times people are like, uh-oh, what do I do when it's equal to 0? Well, we don't have anything against 0. 0 is still a number. It still works. Okay. So once again, we're going to distribute. Now we have two things that we're going to distribute to here. So I have 3x minus 13 and then I get 7x plus 14 minus 4x plus 28. Okay, so then I combine like terms here. Sorry, you're gonna hear my dogs for a second because they're really loud right now. Sorry. So I've got 3x minus 13 is equal to 3x, and I've got 28 plus 14. And that's 42. So I'm going to subtract 3x from both sides of the equation. And I end up getting negative 13 is equal to 42. Now that can never happen. So that leaves me with no solution. Okay, so you are going to need to be on the lookout for questions like that. So when the variable goes away and you get a number is equal to number. So when the numbers are the same, there's infinite solutions. And when the numbers are different, there is no solution. Okay. All right. Now, what happens when we have these proportions? Okay. Well, I don't know if you guys remember, proportions are just equal fractions, right? Things that are equal to each other, equal ratios. So one of the easiest ways to do that, one of the most famous ways of doing this is through percents. When you do is over of is equal to percent over 100. That's a perfect percent. That's what we use all the time. So it's a good thing. So, okay. So what we're going to do is we're going to cross multiply. We're going to do 3 times x. That gives me 3x is equal to 4 times 6. All right. So 3x is equal to 24. And if I divide by 3, I get x is equal to 8. Now you might have already recognized that 3 times 2 is equal to 6. So if I multiply the numerator times 2, I get 8. And that's great. But when we have questions like this guy, that's when they get a little bit more complicated, where it's really going to be beneficial for us to utilize the cross product. Now, when you have a number times an expression, be very careful. You have to distribute that number. So when I cross multiply here, I get 2 times the quantity of n plus 5 is equal to 10 times 4. So I get 2n plus 10 is equal to 40. And then I just do my subtraction. I subtract 10 from each side of the equation. Remember, whatever I do to one side, I have to do to the other to balance the equations out. And I get 2n is equal to 30. My last step is to divide. And I get n is equal to 15. Now I can always go back and check and see. Here we have 2 times what is equal to 4. That would be 2 times 2. So if I multiply 10 times 2, I get 20. And if I plug in 15 for n, that's exactly what I get. Okay. So let's try another one. This one we have variables on both sides of our equation. So I'm going to do 5 times the quantity of y minus 3 is equal to 2 times y. So I get 5y minus 15 is equal to 2y. And then I'm going to subtract 2y from each side of my equation. Now, a lot of people are like, uh-oh, what do I do? And that just means I get 3y minus 15 is equal to 0. Okay, that's okay. We can have 0 at one side of the equation. So now I'm going to bring this 15 over by adding 15 to both sides of the equation, and I get 3y is equal to 15 last step is to divide by 3, and y is equal to 5. Okay, so let's do a couple more. All right, and then we'll keep going. So we've got 5 times 2k minus 3 is equal to 3 times k plus 9. So I'm going to go ahead and distribute. So I have 10k minus 15 is equal to 3 times k, which is 3k plus 27. Okay, then I go ahead and subtract 3k. I always try to bring the variable to one side first. Okay, I always bring the variable over as quickly as possible to one side of the equation after I've done all of my distributing. Okay, so be really careful of that. So I've got 7k minus 15 is equal to 27. I'm going to add 15 to both sides of my equation. 27 plus 15. I am not going to trust my brain right now because it is a Monday brain and I'm just not going to do it. So I used my calculator and I got 7k is equal to 42. My last step is to just go ahead and divide by 7. So k is equal to 6. Now remember, if you ever want to check, you can go ahead and plug that value in. Yes, thank you. Plug that value in and double check and make sure it works for both. Okay. So let's see what else we got going on here. My puppies are very chatty this evening. And I have 3 of them, so that doesn't always help. So we also have proofs, and then I'm just trying to see, and then I know we have literal equations. And we'll do a couple of word problems. Okay, that makes sense. Okay, so I want to go back to some more of these proportions and kind of go from that. So next time we'll do the proofs and we'll do literal equations. So, all right. So I'm going to go ahead and again, multiply both sides to cross multiply. So I do 8 times x is equal to 3 times x plus 10. Always remember to put parentheses. Sometimes what I do is I put the parentheses on the actual ratio so that I don't forget to do that, because then it's just really easy to make little itty bitty mistakes. And again, one of the things that really helps you prevent from making a lot of mistakes is doing it very, very neatly. So 8x is equal to 3x plus 30. And then I'm going to go ahead and bring my variable to one side. So I get 5x is equal to 30. And you see these actually do not take that long to do. So x is equal to 6. A lot of times they're one of the ones that's not hard to do at all, but it's easy to forget. So just definitely be really careful and do lots of practice with them. Okay. Do you want me to do a couple more, or do you want me to go into proofs? Yeah, we'll do the next problem or the next section.
Section.
Okay, let's try it. Okay, yeah, so these are not too bad. So algebraic proofs, actually, you're going to be really glad that you see these because you actually do them in geometry as well. It's the beginning of the proofs, and everybody always dreads proofs, and they're really not that bad. So if you know how to solve an equation, then you know how to do an algebraic proof. And what you probably noticed is that a lot of times when I was solving an equation, especially at the beginning, if I use a particular property or something, I write down that property. So that's all I'm doing is I am justifying the steps that I make to solve the equation, because everything in mathematics is proven. So that's one of the things that we have to do. So I am given an equation to solve. So the first reason for any equation or algebraic proof is given, because you're given something. And then what did I do to get from this step to the next step? Well, normally if I see parentheses, what I'm going to do is distribute. So that's exactly what I did. So to get from step 1 to step 2, I utilized the distributive property. So the reason or justification for me getting to the next step is the distributive property. Okay, so with algebraic proofs, the action that you did is the property that you're using. So if I'm looking at number 2, if I was solving for x, I would add 18 to both sides of my equation, right? And that's exactly what I did. I got 2x is equal to 8. So I utilized the addition property. And then finally, the last step I did to solve for x when 2x is equal to 8 was divide both sides of the equation by 2. So that is the division property. I'm sorry, guys. Okay, moving on. So what I'm doing now is I have this equation right here. The first thing I'm going to do is get rid of this plus 10. So when I do that, I'm going to subtract 10 from each side of the equation. So I am utilizing the subtraction property. And then I get m divided by -3 is equal to -11. So in order to do that, how do I undo division? I multiply, so I'm going to use the multiplication property. Okay. All right, so I'm going to do a couple more and then I'm going to, and so again, as long as you know how to solve equations, you're going to be golden. So what I'm going to do is I'll do this last one and then we'll leave 4, 5, and 6 and this last one for next week or next class. So okay, so first thing I do here is I'm given the equation of 5y minus 1 is equal to 7. So what I did was I wanted to get rid of that divided by 2, right? So what do? I multiply both sides of the equation by 2. So that's using the multiplication property. Okay. Then I added 1 to both sides of the equation to isolate the term with y. So that is using the addition property. And then finally, my last step was utilizing the division property. Let me do one more. What the heck? We've got time, so we might as well. So Okay, here I have variables on both sides of the equation. So this is a great reminder on how to properly solve an equation. So when you don't have to distribute and you don't have any like terms to combine on either side of the equation, the one thing you need to do is bring the variable to one side. So what I did is I subtracted 2k from each side of the equation to bring it over to the left side. So when I subtract, I'm using the shocker subtraction property. And then I have to get rid of that -4. So what did I do? I just added 4. So that's the addition property. And then finally, I divided. So I use the division property. Okay, so really not bad. If you can solve an equation, like I've said, you guys can do an algebraic proof. You just have to tell me what you're doing. What operation are you doing? What step are you doing? And when that operation is the property that you're using, and that's your justification. Okay. Let's look at number 5 and then I'll leave you guys alone. I know I keep saying I'm going to stop and then I go again. So look what happened here. I ended up with just a -42 on the left and a 7n on the right. So what I did is, even though I'm subtracting and bringing it over to the right side, I'm still utilizing the subtraction property. Okay, and then I'm going to divide. So that's the division property. Now, here's a new one. I've now flipped it over. So I said -6 is equal to n, and then I said, okay, now n is equal to -6. That is the symmetric property. I'm actually really glad that we did that one. Okay, so we just put the variable on the left side, we just flipped it over. So that is the symmetric property. Okay, so you have a couple more to do in the packet if you want to try them. I think I have some in Delta Math as well. Next class, we're going to talk about literal equations and these proofs, and then we're going to end up with some word problems. Just a couple of little ones because I want you to start getting used to the types of problems that you're going to see. Okay, just to get you used to them. All right, because it's really important to be able to translate from a word problem and set up some equations. So we're just going to do those together. You'll find that there's only so many ways that you can do it, so it does get much easier quickly. So, all right, so next time we will finish up these next two proofs if you haven't already done so, and then we'll start on literal equations, which is challenging but not impossible. So hang in there. Thank you so much for being here tonight. Have a great night, and let me know if there's anything else I can help you with. All right.